Let's go over examples for the lesson on linear functions. To start off, we'll determine whether an equation represents a linear function or not. When we ask if this is linear, we mean, can it be written in the standard form? In this case, it clearly cannot because x is being multiplied by y. No matter how hard you tried, you couldn't get it to look anything like the standard form. So this is a no. For this, it looks like we may have to do some arithmetic in algebra. I'll start by subtracting y from both sides and adding x to both sides. That way, all I have is a number on the right. So this becomes 3x minus 2y equals 7. This can be written in the standard form, so that's a yes. Now let's determine the x and y-intercepts. For the x-intercept, we set y equal to 0. This means 3x minus 0 is 7. 3x would equal 7. So x is just 7/3. Our x-intercept then is 7/3, 0. For our y-intercept, we set x equal to 0. That means that 0 minus 2y equals 7, or y is minus 7/2. So our y-intercept is 0, minus 7/2. Here we have an equation that is actually already written in a kind of standard form. As you see, all you have to do is just take out the 1/2 and the 1/3. So that's a yes. Again, let's try to find the x and y-intercepts. So for the x-intercept, y equals 0, which gives us 1/2 x plus 0 equals 9, or x equals 18. So our x-intercept is 18, 0. For the y-intercept, we set x equal to 0. This means that 0 plus 1/3 y equals 9, or y equals 27. So our y-intercept is 0, 27. For example 4, we have to graph a linear equation. Let's start by finding the x and y-intercepts. So for the x-intercept, y equals 0, which if you plug it in, you end up just getting that x equals 4. So you get 4, 0. For the y-intercept, you set x equal to 0, and you'll get that y is negative 2. We can plot these points on the graph like this, and now all we have to do is connect the dots. And we have graphed the line. Let's go ahead and try the same thing for this problem. For the x-intercept, we set y equal to 0, and this gives us that x must also be 0. For the y-intercept, we set y equal to 0, and actually no, we set x equal to 0. For the x-intercept, we set y equal to 0, and this gives that y also has to equal 0. So this hasn't really helped us very much, except now we know that there's a point 0, 0. So what we can do from here is we can either just pick a point. Let's say I wonder what y is if I choose x to be 1. And that tells us that y has to be 4. So we can plot the point 1, 4. Or you could rewrite the equation from standard form to point-slope form, like I had before. We have y equals 4x. And in this case, the slope is 4, so we know to go up 4, 1, 2, 3, 4, and over 1. And we get the exact same thing, so we can connect the dots and get our line. Not a very good line, but still. A piggy bank starts off with $20, and every month you put in an average of $10. The total savings, S, can be described, where M is the number of months, by S equals 10M plus 20. We have to graph the equation to begin with. Now this is in point-slope form, so we can just look at the y-intercept as that extra term that doesn't have the M, and we know to start vertically at 20. For the sake of scale, these lines going this way are going to be multiples of 10. Vertically, we can keep it as just 1 for number of months. So we can label our axes M for months, S for savings. Now we can use the slope, 10, to know we go up 10 and over 1. And because of the way I chose my scale to be, up 10 is just one of these ticks, and over 1 is also one of these ticks. So this is the other point. Now all we have to do is connect the dots, and we get the line. To predict when we'll have $75 in savings, we'll have to go up to where y is about $75. In this case, that's 1, 2, 3, 4, 5, 6, 7. It's a little over the top here. And if we go over to where the line would be, we'll see that it would be somewhere around here. And if we go straight down, we know it's going to be somewhere between 5 and 6.